standard completing the square, or sorry, more standard partial fraction decomposition problem. And in fact, the bottom is already factored for you. So we have x squared minus 29x plus 5 all over x minus 4 squared times x squared plus 3. So our bottom is already factored, so doing our partial fraction decomposition should be relatively simple. We know then that our original fraction is going to have to equal to, we need a over x minus 4, we need b over x minus 4 squared. Remember that if you have a double root, you need the single and the double of it, but only, you don't put bx plus c, you only put b because the root is what matters if it's all raised to a power. However, x squared plus 3 is irreducible, so we need to put cx plus d on top of that one. So when you multiply it all out, we get that our numerator over here, so this has to be a times x minus 4 times x squared plus 3. The a needs both things, an extra x minus 4 and the x squared plus 3. The b only needs the x squared plus 3. And our cx plus d needs to be multiplied by x minus 4 squared. So we have a variety of things here. So in this case, we can only plug in to get a lot of things to be 0 in one case, and that's if x is equal to 4. Notice x squared plus 3 can't be 0, so after that we're going to need to do some of the grouping method. But first let's say x equals 4. Okay, so let's see what that means. This term is all going to be 0, this term is all going to be 0. So on the right side, we're going to get 4 squared, 16, 16 plus 3, 19, so we're going to get 19b. Excuse me. If we plug in 4 over here, so what we're going to get here is 80 plus 36, we're going to get 116. 16 minus 116 is going to give us negative 100 plus 5 is negative 95. And that's exactly what we get if b is 5, or negative 5. So we get b equals negative 5. I'm using that. So now you can write that in when you rewrite the next step, because the next step is going to have to be by grouping. So we have a x minus 4 x squared plus 3. So we get minus 5x squared minus 15 by just plugging in the negative 5 for b, plus cx plus d times our x minus 4 squared. Alright, so now we're not going to be able to do anything else in terms of getting terms to cancel out. So we're going to have to do the grouping method, and in this case we're going to have to just expand everything. Excuse me. So here, x minus 4 times x squared plus 3. Remember, we're putting a in front of everything, so this is going to be ax cubed minus 4ax squared. So we're going to get plus 3ax minus 12a. So we have minus 5x squared minus 15. And I'll just start right on the next line here. So x minus 4 squared is x squared minus 8x plus 16. So let me write that there. Just so that distributing in that becomes a little bit easier. So we're going to get plus cx cubed by doing the first ones. We're going to get dx squared and minus 8cx squared as our x squared terms. d minus 8c x squared. For our terms that just have x, we're going to get negative 8d and 16c. And our only constant term is going to be 16d. Alright, so we have a bunch of different things to figure out here. But we can just start grouping them together. So let's do first the x cubed. Well, we don't have any x cubed here. And the only x cubed terms are a and c. So that tells us that a plus c has to equal 0. We have the x squared terms. So we have a couple of different things. We have negative 4a. We have the minus 5 from this, plus d minus 8c. All together have to be 1, because that's the coefficient of the x squared over there. I'm going to write out all of the equations, even though we might not need to use all of them. For the coefficients of just x, we have 3a, we have 16c minus 8d. And that's it for this case. That all has to equal negative 29. And finally our constants. Our constants are minus 12a, minus 15, because we have a minus 15 there, plus 16d has to equal 5. So we have 4 equations, which we only have 3 variables, so we definitely didn't need 4 equations. I just decided to write them all up here. Let me rewrite our actual decomposition up here. Remember that we were getting a over x minus 4, b over x minus 4 squared, and cx plus d over x squared plus 3. Okay, so let's figure out what all of these are. We can just do a couple of different substitutions here. If you notice, we have a and c here, and only a and d here. So we can definitely get d and c just in terms of a, and then we can easily get 1 all in terms of a. So here, c is clearly negative a. We're going to use that. Here, if we add all of this stuff over, we get 16d equals, this would be 20 plus 12a. So d is equal to 20 plus 12a over 16. So we can sub that in to either of these other 2 equations. Let's do the first one because it has smaller numbers. And we'll get what a is. Once we get what a is, we can get what d and c are just from those 2 things. So if we plug in here, we're going to get negative 4a. I'll add this 5 to the other side. Plus d. Minus 8c. C is negative a, though, so that's going to be plus 8a. And that's all equal to 6. What we can do here is we can actually, what you don't want to do is just multiply by 16, because the numbers are going to be huge. We can reduce a lot of stuff here. Everything here is divisible by 4. That would be 5, that would be 3, that would be 4. Multiplying by 4 is a lot more realistic. If we multiply by 4, we're going to get negative 16a. In this fraction, the 4 denominator would just disappear. So we're going to get plus 5 plus 3a, because that's what we were left with on top. That is going to be plus 32a, and this is equal to 24. So you can see here, we have only a's. This is pretty simple to solve. Negative 16 and 32 would be 16. 16 and 3 is 19. And 24 minus 5 is 19. So I just grouped all the a's together, subtracted 5. You can see here that a is 1. Well, if a is 1, then c is negative 1. Remember that our b, sorry I erased that before, remember that b was negative 5. That's how we got this information here in the first place. A is 1, c is negative 1. If a is 1, we can plug that in here to get d. 20 plus 12 is 32. 32 over 16 is 2, so d is equal to 2. So we have all of our numbers now. So our integral becomes 1 over x minus 4, we get a over x minus 4, minus 5 over x minus 4 squared, that was our b, plus, so what's going on top of the x squared plus 3 is we have cx plus d. Our c was negative 1, so we get negative x, and our d was 2. Okay, so we have a bunch of integrals here to evaluate. So I'm going to erase this board, or this side of the board, to evaluate our integral now. So this is just an ln because we have x minus 4, top is just 1. This is just a power rule. We have something to the negative 2 power, raise the power by 1, divide by it. We don't need to do substitution because the derivative of the inside is just 1. It's not going to change anything. This last one we actually need to do a little bit of work with. We need to split it up. So what we're going to get here is ln x minus 4. We're going to get plus 5, sorry, let me write that as a fraction, 5 divided by x minus 4. Remember that when you do power rule with a negative power, when you add and divide by that term, you're going to be dividing by the negative number, which is why this turned into a positive. Remember, you want to think of this here. Get rid of this here. You want to think of this as 5x minus 4 to the negative 2, and work with it like that. This one here, let's deal with this one separately. So what we're going to get is, this is the same thing as the integral of negative x over x squared plus 3 plus the integral of 2 over x squared plus 3. This is an ln, this is an arctan, just like the previous two problems. The derivative of the bottom here is 2x. We would need 2x on the top. If I'm going to put a 2 up here, I need to put divided by 2 there. This is going to be negative 1/2 ln x squared plus 3. So we got 1/2 in front. And when the top's exactly the derivative of the bottom, you know it's just ln. We had a negative sign put in front. Here, the 2 can be in front, and I can just make the top 1, and that's just arctan. However, our a is square root of 3, because a squared is 3 there, so this is going to be 2 over square root of 3 arctan of x over square root of 3. So our full answer is these two things and those there, minus 1/2 ln x squared plus 3 plus 2 over radical 3 arctan of x over radical 3 plus c. We have 4 total terms and a plus c in our answer. So I mean, that was, again, about as difficult a partial fractions problem you could get for the exam, just because of time constraints, obviously. But when you do partial fractions, it should be obvious what you can get. You can either get ln's, you can get power rule, simple things like that, or you can get arctans. Those are really the only types you can get from partial fractions. And